our team for conduct of the conference.
Hello, Dr.
Hello, everyone. Hello, sir. How are you? Good morning.
Very good. Thank you so much for taking pain to join. That too at a midnight delivering keynote is not easy.
Our pleasure. Yeah. Thank you.
Thank you so much. Jawahar used to update me about your conversations and
Yeah,
how things
sure.
are.
Yes.
Yeah.
We were in touch. Yes. So we are just waiting for Dr. Najafi to join, and then we can get started.
Yes. Thank you.
Thank you. So I had a plan to come to home actually in April last. So I planned like May I will be in home. So I belong to Himachal Pradesh. So, but then it got cancelled due to this situation in Delhi.
Okay.
Good morning to all. Our session will begin soon. Please switch on your videos and mute your audios.
Good morning, sir.
Good morning, everyone.
Sir,
Good morning,
Dr.
Professor.
Mohammad Najafi.
Good morning.
A very warm good morning to one and all. It's my pleasure to welcome you all to the first keynote lecture of SECON 21. And before we begin, I request all of you to please switch on your videos and mute your audios till the end of the session. Also, if you have any doubts regarding the topic, please don't hesitate to put it up in the chat box. Now, I welcome Shweta Maria Charles to address the gathering and to introduce our keynote speaker.
Thank you, Seneca. A warm welcome to everyone present here. It is a great honor to welcome the guest of the day, Dr. Mohammad Najafi and Dr. Vinay Kaushal, who will be delivering the first keynote titled An Overview of Trenchless Technologies for Underground Pipeline Renewal. I also welcome the audience who have graced the event with their presence. With great pleasure, I would like to give a brief introduction on our speakers, Dr. Mohammad Najafi and Dr. Vinay Kaushal. Dr. Najafi is a registered professional engineer in Texas with more than 30 years of experience encompassing engineering, educational research, consulting, and management activities. He is the author of several books on trenchless technology and asset management. As director of the Center for Underground Infrastructure Research and Education, abbreviated as CUIRE at the University of Texas at Arlington, Dr. Najafi has led many research projects with more than $3 million of funding secured competitively from funding agencies such as WaterRF, WERF, and TRB. Under his direction, a new Master of Construction Management, MCM, was instituted at the University of Texas at Arlington. Dr. Najafi is an active member of ASCE, ASTM, AWWA, and NASTT. He has served as the chair of ASCE Pipeline Division Executive Committee and was the chair of ASCE Pipeline 2013 conference. Welcome, sir. Now, a brief introduction on our second speaker, Dr. Vinayak Kaushal. Dr. Kaushal is an assistant professor of instruction and has earlier served as a postdoctoral research associate and an adjunct professor in the civil engineering department at the University of Texas at Arlington. He has been actively involved in the industry research projects on sustainable trenchless pipeline construction and renewal technology, and has collaborated in writing several research proposals. Dr. Kaushal is a member of American Society of Civil Engineers and Curate Place Pipe CIPP subcommittee under the American Water Works Association's Pipe Rehabilitation Standard Committee. He is also a member of the Early Career Editorial Board for Elsevier's Underground Space Journal and board member of MDPI's Infrastructures and Sustainability Journals for his expertise in sustainable underground infrastructure. Welcome, sir. Now, let's welcome Dr. Mohammad Najafi for the keynote address. Over to you, sir.
Good morning, ladies and gentlemen. It is my pleasure and honor to present this morning. I would like to share my screen, and if I can do that. I'm looking for share link.
Presenter.
Yeah, okay, I got it. Okay. I think I have it here. Do you see my screen?
Yes, sir.
Yes, sir.
Yes.
Okay, again, good morning. Thank you so much for your nice welcome and your introduction. It is my pleasure to present on the overview of trenchless technologies for underground pipeline renewal. And my name is Mohammad Najafi. I'm a professor and also director of the Center for Underground Infrastructure Research and Education, CURI, at the University of Texas at Arlington. Also, I have with me Dr. Vinayak Kaushal. He is a member of ASCE and a pipeline assessment program for inspection, and also assistant professor of instruction at University of Texas at Arlington. So the outline of our presentation will be about open cut installation and trenchless installation, the comparison, and some information about the market and the history of trenchless technologies. Why should we use trenchless? And then talk about a little bit about sustainability of trenchless methods. and then talk about also about life cycle assessment of the pipeline renewal. And then we talk about some specific renewal methods. At the end, we provide you with some considerations and conclusions. So the issue we have today is pipelines that have been installed about 60, 50, or more than 50, maybe 70 years ago, and due to age and corrosion and loading on the pipe and several other chemical and physical factors are deteriorated and they need to be fixed. So the slide you can see here, it shows all the parameters that work on the pipe, including the soil load, the truck load, construction equipment load that travel on the surface. And then we have differences in temperature that causes contracting and expansion of the pipelines. We have corrosion issues from the outside, and then also corrosion issues due to fluid inside the pipe. And then we have these corrosion holes that cause leakage and creates moisture in the soil. And either groundwater is going to infiltrate inside the pipe, or if the pipe is under pressure, the water is going to go out of the pipe. So it's going to leak. So the soil characteristics are also very important in the corrosion aspects of the pipe. And then also at the bottom, at the bedding of the pipe, if you have holes or cracks, we have leakage. And that leakage will cause washing of the bedding material, and the pipe loses its support. When it loses its support, then it cannot carry the load, and it may create cracks and more problems for the pipe. So all of these impact on the aging pipes, and it's not just the age that causes the problem. It is also chemical, physical actions around the pipe that create deterioration of the pipe. So ideally, if we build our cities according to rules and regulations and in very organized manner, we have different types of pipes separated underground. And so, for example, we have this red pipe, which is the sanitary sewer. The blue is the water pipe. The yellow is the gas pipe. And then, everything is organized parallel to each other. We have also yellow for the storm sewer pipe. And when they age and they require fixing, it can be done easily because the pipe located at certain locations, and you can maybe excavate that area and fix it. However, in reality, in our big cities and center of the cities, we have all of these pipes that are running over top of each other. So if the pipe underneath is broken and requires repair, then you have to excavate from the top all other pipes before you reach the pipes below. So this is creating a major issue for municipalities and major cities around the world. If you want to know the quantity of these pipes, there are more than 3.5 million miles of pipes that are poorly documented. We don't know the location, and the maintenance for these pipes are neglected. and that costs trillions of dollars to fix. So how the pipe is going to be installed underground? It is a very complex situation. Many people, they think that you can dig a trench and put the pipe inside the trench and then backfill. However, pipeline requires a lot of other complex features, such as considerations for the fluids and hydraulics and structural capacity, and also for pressure applications, and also during the life of the pipe always requires maintenance and inspection in order to prevent any catastrophic failure. So when you put the pipe underground, there are two types of considerations. One is the property of the pipe material, and the other one is the property of the soil. So it is like a composite concept, that the pipe and the soil work together in order to work and create the pipe. So in many situations, in fact, the soil does majority of the work because it supports around the pipe, and about 90-95% of the strength of the pipe, especially for flexible pipes, come from the soil, not from the pipe. So that creates a lot of important factors to consider. That includes also the bedding and embedment material for the pipe, and also compaction and providing the required support around the haunch and below the pipe. So when we talk about the pipe, there are two major types of pipes. On the left side, you can see concrete pipe. Most people are familiar. In US also we have vitrified clay pipe, which is basically similar to brick. And then we have pre-stressed concrete cylinder pipe that has a steel shell and a concrete cover around it, which is reinforced with these pre-stressed wires. So that reduces the amount of steel in this type of pipe. And then we have regular reinforced concrete pipe. Also, additionally, we have bar wrap concrete cylinder pipe, which is similar to pre-stressed concrete cylinder pipe. We have also asbestos cement pipe, which is not allowed in US. It is banned since 1960s, but other parts of the world may be using it. And then also we have like a polymer cement pipe that instead of Portland cement, they use polymer to bind the sand and create a pipe. On the flexible side, we have a steel pipe. We have ductile iron pipe, which is a new version of cast iron pipe. And then we have polyvinyl chloride, which is PVC pipe. Also, we have polyethylene or PE pipe. And then fiberglass reinforced plastic pipe. And also polybutylene pipe, which is similar to polyethylene pipe. So these two main types of pipes, one rigid, basically carries the load from the surface to the bottom of the pipe. The flexible pipe, it transfers the load from the surface to surrounding soil. And the surrounding soil will help the pipe to carry the load. So this is more like what I said, 95% soil support. So in 2005, I published the Trenchless Technology book by McGraw-Hill, and this was the first comprehensive book that included all the trenchless technology methods. And by definition, when we say trenchless technology, we are talking about all methods of pipelines and utility installation and renewal with minimum disruption of surface and subsurface. So when we say minimum, there might be some excavation required, like a pit or shaft, but most of the pipe installation or renewal is done without any type of digging. So how the trenchless technology industry was developed? There are some events that happened in the US. Some organizations formed, like in 1976, NASCO, National Association of Sewer Service Companies in US was established. In 1985, there was a conference in London that they decided to set up a trenchless technology industry, and so they call it no dig. And so the trenchless industry was society was called ISTT, which is International Society for Trenchless Technology, back in 1986, out of the conference in 1985. And then in 1989, there was a Center for Research at Louisiana Tech University, which was established. And then this center, which is called TTC, conducted several seminars. And in 1991, a NODIG conference was presented in Kansas City, USA. And there was an international NODIG in 1992 in Washington, D.C. And then there was one or two centers at different universities, such as University of Waterloo and also Michigan State University, and also Curie, which was moved to University of Texas at Arlington. ASCE, which is American Society of Civil Engineers, started publishing several manuals of practice, such as guidelines for macrotunneling in 2001, and also 2004 for horizontal auger boring. And then, as I said, 2005, we published the trenchless book. In 2010, I published another book on trenchless technology on the installation and inspection aspects of it. So considering open trench or open cut installation or repair with the trenchless technology, you can look at all these parameters on the left side that are a major issue for open cut, and minor, one or two of them are moderate or major to moderate for trenchless, such as soil conditions need to be very well identified for trenchless technology, and existing utilities have to be identified and located, because otherwise, if you go blindly and you do not see where you excavate by trenchless, then you may hit those utilities. So otherwise, for open cut, like water table is a major issue. You have to dewater the trench, and the traffic control is a major issue for open cut. Safety issues, when workers work in the trench, there is a possibility of cavings And that's a major issue. This is a major cause of accidents and injury and death to workers in the US. And the productivity is a major problem for OpenCut. A project may take 3 months. For OpenCut, it may take a week or a few days for Trenchless. So Trenchless is more productive than OpenCut. And then as Dr. Vinny Casual will talk, the environmental impact of the OpenCut is a lot more than what it is for Trenchless, considering the emissions and fuel consumptions and other things. Another feature of Trenchless is you can go shorter distances instead of going around the river or road, and just go directly from point A to B. And that allows for shorter distance and a smaller diameter of the pipe and less maintenance and operation cost, and also overall the life cycle cost. So this is a routing benefit for Trenchless technology. This photo shows the damage that caused by open-cut excavation. Workers in the trench, there is a safety problem. They spoil the cuttings on the site, which is a danger for the workers, and also damage to the trees and green areas. And then also the traffic disruption, maybe road is closed or a street is closed, or at least one lane is closed. Heavy equipment that produce a lot of noise and dust and pollution, and create a lot of disturbances to the neighborhood, are working for the trench excavation. And when they put the pipe in the trench, they need to bring a select soil to embed the pipe. That hauling the material is a major environmental impact, taking the native soil out and bringing the select soil in. And then also compacting the embedment is another issue. When you compact, you actually damage the pipe at the beginning of the life of the pipe. So these considerations are very important when you consider open cut with trenchless. Another issue is when you dig a trench, you damage the pavement, and the life of and the life of pavement will be reduced because you get lateral cracks and settlement on the pavement. When you close the street, the businesses around the street, they lose their customers, because the customers, they cannot easily get to that business. And like this service station gave a discount during the construction. So the customers would be coming back. They have an incentive to come back. And many times when customers go to a different supplier, such as a restaurant or service station, they may not come back to the original one. So again, when you compare OpenCut with Trenchless technology, you can see that overall budget for the project, if it is fixed, most of the cost of the project for OpenCut may go to social cost, which is traffic control or reinstatement of the ground, shoring of the trench, and backfilling, compaction, all of these activities which really not required. So around 40 to 70% of the budget goes to type of work that really is not needed for pipe installation. For trenchless, in comparison, only 5% of the budget goes to these social aspects. Most of the budget goes for the pipe, the material, which is a better pipe material than open cut. And then also the labor cost, because the labor is more specialized and educated than the other labor for the open cut. So you have more of the labor cost for trenchless. For open cut, you have 30%. And we can see the material cost for the pipe might be less than the material cost for the trenchless, because for trenchless technology, you are using a better type of pipe, which is the objective of the project, to use a better quality material. So what I'm saying is, for the trenchless, most of the budget is spent over the things that give you a better quality project. For open cut, most of the budget is going to be spent for things that are really not needed or is not related to the objectives of the project. So Dr. Vinaya Kajur will continue with these environmental, social, and economic aspects. Go ahead, Dr. Vinaya.
So Dr. Nafi, do you want me to like share the screen, or I go this way?
Or if you want, I can change it for you.
Okay, yeah, that's fine. Sure. So thank you, Dr. Najafi, for just giving a glance of trenchless technology. So now I'm going to continue from here regarding the sustainability aspect of the pipeline renewal. So as sustainability or having a count of carbon footprints is a hot topic nowadays, be it is any type of construction or any type of new work. So the idea is to have a minimum possible impact on the environment. So with this idea, this diagram, this is called as triple bottom line, or is also called as three pillars of sustainability. So in this, the idea is to keep into consideration the environmental cost, the economic aspects, and also the social aspects. As Dr. Najafi talked about, the social aspects such as traffic disruption, which are dealing with the open cut installation, which is very minimum for trenchless, close to 5%. So these are the factors which you can see on the left, such as community values or buildings, or energy or ecology actually, and site development, mobility, what are the water consumption aspects, what how much waste is generated, and financial implications, and if there are any corporate social responsibility involved. So as a whole, these things contribute towards the sustainability or the sustainable development of pipeline renewal. So next.
So, Dr. Vinayak, you want me to stop? I found it here. You want me to stop sharing and you can share your screen?
Yes, yeah, I think.
Okay, I stop right now.
Sure. So just wanted to check if you can see the screen.
Yes, I can see the screen.
Okay, okay. So next, I would like to say about the life cycle assessment of pipeline renewal. So whenever we go for life cycle assessment, which is very much needed so far as to assess the life cycle of any product, and for that matter here the product or the thing which we would like to assess for the life cycle is pipe, of course. So this is a scientific method for analysis of the environmental impacts which are associated with the life cycle of the product. And this is as per the ISO standards, which are 14040, which talks about the principles and framework, and 14044, which is requirements and guidelines. So what happens is that for any kind of work, such as here we talk about the sustainable development of pipelines. So for any pipeline project, the energy and material inputs are given right from its raw material, which are the materials which will be useful for the production of pipe, and the material which is going to be processed for the production of pipe. And finally, we get a product which is manufactured, and its transportation to the site and disposal. And this concept is also called as cradle to grave analysis, or life cycle of any product, right? So the energy and material inputs are associated with each of these steps, and these are input in the form of the energy and how much material is used. So there are several softwares which could be used, like one of the EPA verified software is called SEMA Pro. So what does that software does is that you need to input the energy and material data for each of these steps, and it will give you the emissions in the form of how much carbon dioxide is used, or how much carcinogenic or non-carcinogenic, or how much is the global warming impact on the atmosphere. So this is the thing which will let us know the initial implication of that project, and we could kind of modify at each of the step which has not been done, so as to minimize the overall emissions which are going to be, or which are anticipated in time to come. So now the challenge is to make a right choice between so many methods which are available right now in the market. So this is a flow chart which gives all the trenchless methods, which are divided into trenchless construction methods, which are also called as TCMs, and trenchless renewal methods, which are also called as TRMs. Now, for the scope of this presentation, we are just focusing on the renewal methods, which are more common and as a whole, which are generally used for the renewal of pipelines. So here are some of the factors which impact the trenchless construction methods and trenchless renewal methods, such as the location of the project. So few methods are also site specific, and so far as the experience of the contractor or the person who is doing the job is concerned, so that directly impacts the accuracy of the project and efficiency of the project. How much is the installation length or the size of the project, basically? So how much is the diameter range of the pipe we are gonna deal with, whether it is a small size or medium size or a large size. So small by small, we mean by like 4" to say like 24" and medium size is like 24" through 36 or 42", and then more than 42" diameter or say like 60, 80 all the way up to 120". So these are like main entry and these are called as large diameter pipes. And type of application, so what these what that installation applies to, what is the application of that installation, the type of equipment which are going to be used for different types of projects. And here is the operator's experience comes into play, whether he's experienced or he's a new one. So, and of course, if there are any hindrances or what are the surface and subsurface conditions available. So these are the factors which pretty much depends and monitors the use of TCMs and TRMs. So I'm going to start with the renewal methods. And to begin with, I go with cured in place pipe, which is also called as CIPP. And I go over some of the methods and then rest of them Dr. Najafi is going to cover and until the end. So CIPP, which is cured in place pipe, it was introduced in 1971 as an alternate to the open cut, digging up and replacing the sewers. So here, as you can see, so there are two manholes. One is inlet manhole and one is outlet manhole. So the process of CIPP involves a liquid thermoset resin saturated material which is inserted into the existing pipeline which has been deteriorated. So now from the inlet manhole, the liner is inserted and is basically saturated with the help of hydrostatic means or air inversion by mechanically pulling in and inflating. So here, as you can see, this is a outlet manhole. So and it is cured by various means such as the hot water, steam and light cured using ultraviolet light, and the end product of with the help of this type of trenchless renewal method would be like this. So this, as you can see, the outer one is the original pipe which is initially is deteriorated, and with the help of this method you can see another kind of pipe which develops as a result of this method, and this is called as CIPP liner. And for curing, as I said, there are different types of resins which could be used, like polyester, epoxy and vinyl ester. So here you can see how the liner goes inside the inlet manhole all the way towards the outlet manhole where so this is like the outlet manhole. So this goes like segment by segment, manhole by manhole, and on the top the normal activities can continue. So there are no obstructions to the traffic, and then there is no reinstatement of surface. So here are some of the applications for this type of method. So it could be used for sanitary sewers, also for the gravity collection systems and storm sewers systems. Also the pipelines or the small diameter pipeline or even medium size laterals which are coming from the buildings and they connect the main sewerage line, or could be renewed with the help of this method. And this is industrial corrosion protection for structural integrity. So this is claimed to be a structural method, and it does provide structural strength, and it could be used as a structural support system as well. And also it could be used for pressure pipes and ventilation systems. So these are some of the applications. So next I go on to the closed fit pipe. So this is also called as CFP. So this also could be used for gravity or pressure main renewal techniques. And usually there is a reduction of, or the temporary reduction of medium density polyethylene and high density polyethylene, which is HDPE pipe, to allow for the installation within the host pipe. So we will see in the following slide how in the host pipe there is a pipe within a host pipe, which actually accounts towards the reduction in its pipe diameter, and it is restored to the original diameter to form a tight fit against the inside wall of host pipe. And this could be used both for structural as well as non-structural lining systems. And here are some of the characteristics of this method. Like for the diameter range is usually for closed fit pipe for structural support. It ranges from 3-inch through 24-inch, and it can go as long as 1000 feet. And the liner materials which could be used are both HDPE and MDPE for both pipe structural and also for the non-structural applications. And for the types of pipelines, it could be both could be used for both gravity and pressure pipelines. So this is how the liner gets into the host pipe, which is deteriorated or in a bad shape. And obviously at first it could be seen to reduce the diameter, but after it tightly fits into, so initially it could give a temporary reduction in the diameter, but then at the later stage it is not that much as it appears to be. So this is how the pipe like HDPE or MDPE, it goes through the existing pipe which is deteriorated, and this is how the closed fit pipe renewal method it works. So the benefits are like it is used, or it uses thin-walled polyethylene pipe, which reduces cost. And the closed fit or thin wall, it maximizes the relined bore. And also the wall thickness is it does not give full pressure rating, and it relies basically on the host pipe, which has been now renewed for structural support. And it can line a variety of host pipe materials. So this is open to very many pipe materials. So it is not very pipe material specific. So next I'm going to go over the thermoformed pipe. So this is another method for the removal of deteriorated pipes using trenchless technology. So in this method, the plastic pipe is deformed at factory into a shape that will basically will allow it to be inserted into host pipe. So it pretty much depends on the host pipe, and depending on that, the plastic pipe which is going to be inserted will be deformed at the factory. And after being inserted into the host pipe, which is the old pipe or the deteriorated pipe, the deformed pipe is restored to the original size, and it forms a tight fit against the inside of the older pipe or the host pipe. And the availability of pipes is basically, for the structural applications, it ranges up to 24-inch diameter, and for the non-structural applications it ranges up to 60-inch, which is 5 feet diameter, and the diameter it ranges for the thermoform from 4-inch to 24-inch, and the maximum installation it can go as much as 700 feet. And usually the liner materials which are used is polyvinyl chloride, which is PVC. And the typical applications are gravity and pressure pipelines. So this is how the liner would be inside the host pipe. And depending on the shape and size of the host pipe, it would be modified in the factory, and then this is the product which we're gonna get finally. So this is how the liner goes inside, right? And we get the product something like this. So there are this fold and form method, so similar to this. So this is this gets into the old pipe or the host pipe until we get the product like this. So the benefits are that we it is pretty much factory manufactured, so we can basically have the size or shape depending on the host pipe. And the factory control, there is a quality control involved, so we can see for the quality of the work which we want to do at the site, and also for the liner, its size and shape. Its long continuous length, so this is one of the major benefits. And for the variety of pipe wall thicknesses, it ranges, and we have got a different sizes, so it is not very much specific to some particular wall thickness, and is virtually no annular space in between, so which is a good thing. There is no odor involved in this process or at the end even, and PVC could be used, and it usually ranges between 6 to 20-inch or 24-inch. So next is slip lining and modified slip lining. So this is another one of the popular methods for the renewal of pipelines using trenchless technology. So in this method, there is an installation of a new pipe within an existing pipe as a structural renewal, and the slip lining pipe is basically pulled as a continuous pipe or is pushed in segments. So there are small segments of pipe, and as a whole these are pushed segment by segment, and then it could be welded, the joints could be welded, and then grouting program to fill the annular space between the host and slip lining pipes, so like the case for the segmental pipes. So the method which are used be segmental or continuous, as I just mentioned. So the diameter which ranges for the segmental, it goes from 4-inch through 158-inch for the diameter, and the maximum installation for both of them, segmental and continuous, goes as much as 1000 feet. However, the diameter range for continuous is ranging from 4-inch through 63 inches, which is again a large pipe size. And the liner materials basically are PVC and GRP for segmental, and polyethylene and PVC, which is polyvinyl chloride, for continuous. And it could be used both for gravity and pressure pipelines. So this is how the pipeline, like for the continuous and for like segments, how these go. So there are certain limitations involved in this method also, like shaft excavation is required like this, and and this basically also reduces the diameter. So it's basically typically equal or increased capacity. And for the curves, it requires shorts, fittings, or excavations. So usually it does not work very well in case of curves. So it's usually if go straight or very less curves or not very sharp curves, then it could be used. And for the service lateral reconnections, is basically typically point access is required. So usually we are not very sure for this service lateral reconnection. So in that case also, if we are not very sure or we are not sure about the point access, so then this could not or might not work. The benefits is that if there is minimal disruption and then there are no, it goes continuous or all the way straight, then this could be one of the best methods which could be used. And it solves the pipeline problems such as the structural leakage or corrosion deterioration, or the hydraulics is poor. So in that case, this method could be used. And as you saw in the pipe characteristics, so it can go as much as 158 inches diameter. So it can go all the way to large diameter range. It is cost effective, and local contractors can do this work. So you don't need very expert or people with much expertise. So local contractors can handle the work. And similar to this, there is another method which is called as modified slip lining. So modified slip lining is basically for the installation of new pipe within the host pipe. And the slip liner is a close fit installation. So there are three variations of modified slip lining methods. So one is the panel lining, one is the spiral wound pipe, and one is formed in place pipe. So by these methods, what does that mean is basically the difference in the characteristics. So for the diameter range, the panel lining is basically greater than 48-inch diameter. For the maximum installation, it varies basically, and liner material GRP could be used, and the typical applications would be gravity pipelines, not the pressure ones. For the spiral wound, it usually ranges in between 24-inch through 100-inch, and the maximum installation in feet is 1000 feet. The liner material which is used for modified slip lining for spiral wound is PVC, and gravity pipelines again are the typical applications. For the panel linings, it usually is used for the structural renewal, and these are, as the diameter is ranging in between somewhere like 50-inch, 60-inch, or more than that. So it is a worker entry diameter. It can accommodate different shapes, and usually fiberglass material is used in this case. And the products include the channel line and in situ foam armor grip. So these are usually the products which could be used for the panel lining case. For the spiral wound pipe, it uses a layered composite polyvinyl chloride liner with cementitious grout, and it has got a ribbed profile and grout which usually produces highly integrated structure, and the products include Danby and Riblock. And here you can see the spiral wound pipe. So how how from inside. And the last one, which then I'm gonna hand over to Dr. Najafi, is inline replacement. So inline replacement, usually it refers to methods that either burst. So usually by bursting, it means that to burst or split the existing pipe, which is the host pipe, and pushing it into the surrounding soil while replacing it with a new pipe simultaneously. And or there could be another possibility wherein you remove the existing pipe by reaming or eating or extracting the host pipe and inserting a new pipe um, in that case. And pipe bursting, usually it came somewhere same as CIPP in 1970s, and it can be used to replace the deteriorated or out of capacity water or sewer and gas pipes, or usually like when we say out of capacity water, or so in hydraulic where there are some hydraulic issues, etc., could be used. So what is basically the pipe bursting concept is usually, as you can see in this animation, so is the replacement of the host pipe by fragmenting the existing pipe and installing the new pipe of equal or even larger diameter in its place. So it has got the benefits such as it can shorter the schedule duration. It provides a replacement rather than repairs, so you can be sure about the product that you have installed a new pipe and you haven't gone for some localized repairs or some repairs which basically could happen, or the issues could happen, or the problems could happen in the near future. So there is no need for new easement, and it maintains or increases the hydraulic capacity, as I said, if there are some hydraulic issues. And there is a minimum excavation which is required, and it reduces adverse impacts from noise, dust, traffic, rerouting, etc., which accounts towards environmental and social issues, which we discussed in the very beginning. And naturally, it has got a lower environmental impacts, so it can give lower carbon emissions and lower footprints. So basically, pipe bursting, had it receives energy to break the old pipe from the pulling cable or rods, or pneumatic power to the head according to the bursting system, as you saw in the animation also. And the energy is basically transferred to the old pipe by breaking it into pieces and expanding the diameter of the cavity. And with that, we could also be able to insert a larger diameter pipe and also improve the hydraulic issues if there are any. The head is pulled through the old pipe debris, creating a bigger cavity behind it, and the new pipe is pulled from the insertion shaft. For the inline replacement, it varies or can go up to 48-inch diameter, and the driving length could be as much as 1500 feet. And a 15% and 32% increase in the pipe inside the diameter combined with the smoother pipe surface can produce 100% and 200% increase in the gravity flow capacity respectively for both the cases. And it has been also seen through the previous studies that the pipe bursting can also be a cost-effective method wherein it can save up to like 44% with average savings of 25% compared to the open cut installation. And this technique is most cost advantageous compared to the other renewal techniques which we have seen. When there are few lateral connections to be reconnected and the old pipe is structurally deteriorated and the additional capacity is needed. So almost all types of pipes can be burst, like clay pipe or cast iron, steel and ductile iron, HDPE or PVC, concrete, not feasible wherein we have a reinforcement. So if it's just concrete pipe we can, but not in the case of reinforced concrete pipe. And also it can be done for asbestos cement pipe. So existing pipe consideration. So basically this technology is selected based on many factors such as the pre-construction inspection results, if there are existing pipe bends or what kind of pipe failure, if it is a brittle failure or the type of the pipe depending on its type, and if it is previous point repair type material and now it has failed, the type of soil conditions and the availability of the working space. So almost any type of pipe can be installed when the older pipe is burst. So for the continuous one, which is pull in place, HDPE, PVC, ductile iron and steel could be used. For the sectional, which is push in place, clay, fiberglass, polymer concrete and concrete could be used also. So for the applications, it could be helpful for replacement for the water pipe, sewer service laterals, gas pipe and communication ducts, and for replacing the size for or for the upsizing applications. But for in addition to this, there are certain limitations as well, such that the insertion and pulling shafts, they are needed especially for the larger bursts. And for the drive and reception shaft, the circumstances may not permit use of enlarged manholes, so it could not be very much possible. And working space needed above ground for ancillary construction equipment. And usually bypassing the flow is required, which probably sometimes is not possible. So this is one of the other limitations. And there are also the possibility for noise and vibrations. So there could be some sound issues or like noise pollution, etc. Possibilities of surface heaving and damaging the nearby utilities. So you could inadvertently hit the nearby utilities causing a trouble, and also the possibility of damaging the new pipe during the pull-in operation. So this is an overview of inline replacement applications and limitations for different types of pipelines and for which it is suitable for. And here are some of the extra notes or points we got to be aware of. Like, for example, gas pipelines, yes, it is suitable, but we need to avoid the gas pockets. And similarly, for the other types of pipes, so these are some of the warnings or alarms. So for example, for the pipelines with deformations, so you got to, it is possible, but got to be inline replacement. It can also remove the deformities. So this is so usually the static process is more common than the pneumatic one. So these are the steps. So there are 3 steps which are followed in this pipe bursting process. So in the first step, as you can see, the bursting rod is installed in the old pipe. So it's the hydraulic jack is used in this case. So the hydraulic jack is put in the pit and then the rod is moved forward. And then you can see in the next, the rods, these are collected and it breaks the old pipe. You can see here. So so when it goes forward, it breaks the older pipe. And at the same time, the new pipe is installed. As you can see here, so new pipe is installed, and depending on the diameter, how much we need, whether we are going for upsizing it. So we can go back and forth and increase the diameter of the pipe. So this is a project which was done in the Michigan state using the HDPE pipe to replace the older sewer pipe. So now I'm gonna request Dr. Najafi to take over and go over the next methods. Thank you.
Okay, thank you, Dr. Casual. I'm going to continue the other methods and then wrap up the presentation. So I share my slide. Do you see my screen?
Yes, Dr. Miller.
Yes, sir.
Okay, so I continue. Dr. Vinayak presented inline replacement. I go over localized repair. So localized repair can be done if the pipeline is in good condition but has at certain locations cracks or holes or joint issues, joint settlement. So the trenchless technology methods can fix those areas, not to replace the whole pipeline or go from manhole to manhole, just those locations. So there are some benefits to this method. It can maintain the load bearing capacity of the pipe and also add to structural capacity at the certain locations, and also seal the pipe to minimize or prevent infiltration, which is water coming in to the pipe, or exfiltration, which is water going out. And also, if there are missing sections of the pipe, it can be replaced. There are several methods. One is robotic. The robot can do the grout and the fixing of the locations inside the pipe. And there are also some other methods that can be used, such as grouting, spraying inside the pipe at a certain locations using chemical grout. Internal seals are sections that you can insert inside the old pipe and fix that area. Requires a special sleeves. And also the CIPP method that was presented previously can be used to fix certain locations. So the methods include, as I said, robotic, the grouting, internal seals, and point CIPP. The other trenchless method is for service lateral renewal, and a range of different types of methods such as grouting, CIPP, close fit, pipe bursting, and also spray applied pipelining can be used. The most common for the service laterals, which is sanitary sewer, is around 4 to 6 inches, and the water lateral is about 2 inches, very small diameter. It can be done using pipe bursting and CIPP. Those are most common methods. So again, the length of the service laterals are not very long, it's about 100 feet, more or less. And as I said, the sewer lateral may be around 4, 6, or 8 inches. For sewer lateral, it can be used for gravity follow. So this is the CIPP that is inserted inside the old pipe and then cured with the resin. And so a short section can be used for service lateral. And the bursting method, like what Dr. Vinayak presented, can be used, pneumatic head or a static head can be used to break the old pipe and install a new pipe. Thermoform pipe also can be used, as you can see, is inserted through the manhole or clean out and then inserted inside the old lateral. Spray applied lining also can be used using a nozzle for larger diameter service laterals, maybe 8 inches. So, spray applied lining overall, it can be done using manual or using spin cast, which is not using a person inside the pipe. They can use cementitious materials or polymeric like polyurea, polyurethane, and epoxy to fix the pipes. So as you can see, spray applied pipelining is one of the methods. And so as I said, worker entry or non-worker entry can be used. And there are several types of cementitious or geopolymer, which is a mix of cement and fly ash, can be used, or also polymer with fly ash and cement, and also polymers such as polyurea, polyurethane, and epoxy. So the worker entry is possible if the diameter is big. And also you can use reinforcement of mesh such as shotcrete or gunite. And non-worker entry, as I said, we can use the nozzle inside the pipe spin cast and spray the material, which is epoxy and vinyl ester as well as polyurethane install. So the length of the installation can go about 1,000 feet, and diameters can be very small to very big, 180 inches, can be used for gravity and pressure pipelines. So here you can see the spray inside the oil pipe using the nozzle. This is the manual spray. And also you could use the spin cast. So compared to other types of liners, such as a slip lining or curing press pipe, SAPLs can also compete. Actually, they are developing very fast. They have a benefit of quick back to service and quick curing inside the oil pipe. And they don't close the service laterals. And as I said, there is a big range of diameters you can use. And also you can use it for a structural and non-structural, for pressure and non-pressure pipes. So this is a big advantage for SAPLs and for pipes that are hard to reach. SAPLs are more suitable than the CIPP or slip lining. So the last one is the manhole. As you know, for sanitary sewers, we have every 300, 400, like 100 meter, we have a manhole or maintenance hole. So those manholes also require maintenance and repair and renewal. So the trenchless methods can be used to fix them. The manholes can be deteriorated and have groundwater infiltration into sanitary sewer or water from surface coming in inflow to the manhole. So you are paying for the extra fluid or water coming through the rain or groundwater in the treatment plant. So if the manholes can be fixed, you save a lot of money by reducing your treatment costs. So when you consider manholes for renewal, you need to know the type of defects and what is the physical characteristics of the structure, such as whether it is concrete or brick, location and the condition, the age of it, and then the original construction method that was used to build a manhole, and what is the availability of the contractors to use trenchless methods, and also the cost for different methods. So this table shows the different manhole renewal methods and the type of material and the typical application, which is sanitary sewer. So as you can see, grouting or fiberglass insert or epoxy, urethanes, or cementitious material, PVC, can be used for manholes. So this is a big market in the US. We have over 20 million manholes in the US, and 4 million are about 50 years old. So that means deteriorated. Over 5 million are 30 to 50 years old. And every year in US, they spend about $100 million to renew those manholes. And the annual expenditures estimated to be 500 million. So it's going to increase. And you can see the type of deterioration of manholes. Sometimes the sewage is coming up to the surface from the manholes. So to conclude, there are several considerations for using trenchless technology to renew the oil pipes. You need to look at the project conditions, surface conditions, subsurface conditions, look at the life cycle cost of the technology, social costs, environmental impacts, constructability. And another factor to consider, there are some hybrid methods coming to market, and you need to consider those. They provide more benefits than original methods. So in order to make a decision, again, you need to look at bypass pumping, whether needed or not needed, and what repairs can be done, whether cleaning of the old pipe is required or not, whether you need to excavate a shaft or a pit, and then what is the depth of the pipe, whether you have curves or bends in the old pipe, what is the labor cost for installation, and any environmental restrictions, like for odor control or styrene. Sometimes the polymers, they have some hazards for the public, so you have to consider that. So that concludes our presentation. Our information is here. You can email us. My email is najafi@uta.edu. And Dr. Kajul is vinayak.kajul@uta.edu. And also we have curie.uta.edu as our website. So we appreciate the opportunity to present. I know it's morning over there, but now is about 2 a.m., 2 in the morning in US. So we are happy to present and appreciate the opportunity. And if you have any questions, we are happy to answer your questions at this time.
Thank you, sir. Now, if
Thank you.
anybody has any doubts or require clarifications about the topic, please put it up in the chat box. To the attention of participants, there'll be a feedback form which is available in the chat box. Please make sure that you fill it so that you can receive your certificates. Nobody has any queries, then let's move on. Now I call upon Catherine to deliver the vote of thanks.
I deem it a great honor and privilege to propose the vote of thanks on this occasion. Before anything else, let me thank Almighty God for His grace and blessings in our lives. Our sincere thanks to the chief guest, Dr. Mohammad Najafi, the director of the Center for Underground Infrastructure Research and Education, Department of Civil Engineering, University of Texas, Arlington, USA, for gracing today's occasion. Indeed, it was a great opportunity to hear your thoughts on the advantages of trenchless technologies over the conventional open-cut methods, and this shall definitely encourage us in our future endeavors. Your thoughts have enlightened our minds and shown us a new path. A special thanks to Dr. Vinay Kaushal, an adjunct professor, Department of Civil Engineering, University of Texas, Arlington, USA. A special mention to our HOD, Dr. Unikarta Ji, Civil Department Facade, for being the catalyst that inspired us to do our best and who stood with us as a pillar of strength. With a deep sense of appreciation, I thank our loving teachers and students for their untiring efforts. I also thank each one of you for being attentive and sincerely cooperating with us. Thank you.
Thank you for everyone, to organizers, our distinguished guests, ladies and gentlemen, and we appreciate the opportunity and wish you health and happiness and be safe. And we thank you for the opportunity. Dr. Vinayak,
Thank you,
want to-
Professor.
Thank you, everyone. Yeah, we really appreciate it, and we like being here. And thank you for the opportunity, and wish you all the best. And stay safe and stay healthy. Thank you.
Thank you so much.
Thank you so much.
Thank you, Vinayak.
Our best
Thank you.
wishes.
Thank you, Professor.
Bye.
Thank
Thank
you.
you.
Take care.
Thank you, sir. By that, we've come to the end of the session. And now, participants, please join back at 1 o'clock for our second session. Thank you all.